Hi everyone, welcome back. In the previous video we have seen how we can determine the key factor. We have seen the susceptibility of soil to erode is highly related with the four soil properties such as organic matter content, soil texture, soil structure, and permeability. And we have seen different kinds of equation, and we also used to calculate key factor using a nomograph. So in today's video tutorial, I want to show you how I can compute by using ArcGIS and HWSD viewer, and how I can develop a soil key factor raster file. I will go straightly to the steps. What you are going to do is, first of all, you need to download both HWSD soil raster, and you need to extract this raster file, and you need to download soil database also. Then you will add this soil raster in your ArcMap and adjust your projection, or make sure your projection is in the proper format, and make sure that the coordinates of the raster properly matches the shape of your study area. So I'm going to ArcMap, then add this is HWSD raster, soil raster. So add this file, add your watershed area. For me, my watershed is this one. WGS coordinate system is WGS, so add this one. This is my study area. Then add. Then I need to extract my study area soil. So the next step is using spatial analysis tool, and by using extract by mask tool, I need to extract my watershed soil. So go here, Arc Toolbox, then spatial analysis tool, then extraction, extract by mask. Before computing this one, make sure my study area projection is in WGS, not in UTM, because this HWSD.pil raster file is in a geographic coordinate system. So as you can see, the units are in decimal degree. So make sure this is in a WGS coordinate system. So now extract by max. So this input raster is this one. HMS data is this one. So locate. I need to store my extracted soil file here. Give it a name, soil. Save. Okay. For extraction, I need to remove this one because this is a huge raster file. So it helps my ArcMap help easy its work. So I need to remove this one. So zoom tool here. I have three types of soils. So what will be the next step? You can also view soil properties using harmonized worded soil database, HWSD viewer. So before that, I need to use a conversion tool, then from raster to polygon. In order to view in HWSD, I have to change this soil raster into a polygon. So conversion tool here, from raster to polygon. This is very easy. Input raster, this one. Field value. Okay. Give it a name and a folder. Raster to polygon. Study area, study soil. Soil.shp, it will add here. So okay. So I no longer need this one. Remove. As you can see, this is my soil in a polygon format. So I need to add this polygon into HWSD viewer. Open this HWSD viewer. Download this application, which is available for free. So open this one after you install this HWSD viewer. Install and then open. Then click load HWSD. Here there are buttons. You can zoom by rectangle. Click this one. then zoom. This is my study area. Now I have to add the polygon here. Add shapefile. You can add into this window by clicking this one. You can add your shapefile. So up one label again. Here raster to polygon. Add this one. Yeah. Now zoom. The shapefile coordinate system should be in a geographic coordinate system. Open attribute table from extracted soil and take the value field and obtain information about this value field. So here, now ArcMap, click this one and right click, open attribute table. As you can see, this is the value 16735. This is SCMU table here, 735, 768, 769. I have already put here. Then grab the information for this soil main unit, SCMU value, soil property. Grab the information, this for information. You can grab or get from this HWSD viewer. So now click this one, SCMU table, soil map unit table. So click this one. Now click onto this one. You will see the selected SCMU or soil main units value is this one. So for this soil unit, there are information here. These are all the information for this soil unit. So I will go to this row, topsoil, which has a depth of 30 centimeters. So for this depth of soil, it has a topsoil sand fractions of 51 for a dominant soil. So for silt fraction 22, for clay fraction 27, and organic carbon content 0.63. So I will copy these values into my Excel. 51, 22, 27, 51, 22, 27, and 0.63. As you can see, 0.63. This is organic carbon, this is clay, silt, and sand. So in such a way, you need to add also for 768. Here again, go here in this box, click this one. For this soil, the topsoil sand fraction is 24, the silt fraction 27 and 49, 27, 49, 24, 27, 49, as you can see. And organic carbon content is 2.45%, as you can see, this one. So you have to add this information. There is also a description for this soil layers. There is a textural classification according to USDA. So for this soil unit, the soil texture is clay light. So you can grab those information. This is for from 30 centimeter to 100 centimeter information. There is a sand fraction, silt fraction, clay fraction. So we don't bother about this layer, soil layer, because the topmost soil is highly prone to soil erosion, and it is directly affected by soil erosion. So I need to use 30 centimeter depth of my soil layer. So 16,768, the soil properties you can get in such a way. And for this one, click this one. The same soil properties you can get for this soil unit. So the soil texture also you can read from this one. Now I have got those soil properties, so I no longer need this HWSD viewer. So close this one. Now for this soil unit, the dominant soil, chromic Levy soil. For this characteristic soil, the soil unit name is chromic Levy soil, and for this one, it is humic Levy soil. This is the same soil. So such unit names also found from this HWSD viewer. Then the next step is determining key factors. So in order to determine key factors, we need to determine the four important parameters for key factor: M or M organic matter, S structure, and P permeability. We need to determine these four parameters in order to determine the key factor. So for this case, first one is S and P. I use this chart in order to determine the S factor, this value, soil structure value. So For this case, from the graph, percent sand and percent clay are available, so you need to use these values for soil. The first soil unit for 51 here, for 51 this line, for 51 and 27 clay, the soil is here arranged in this section, which is in the orange section. So the soil is sandy clay loam, and the soil structure is in orange section, which is type 4. As you can see, type 4. So S value will be 4. For the corresponding soil map unit for this one, for 24 and 27, sorry, for 24 and 49, you can get as the soil is clay. For this one, 24 here, and 49, almost 50 here in this region. The soil is clay, and the soil structure code is 4. S value will be 4. So all are S value will be 4. From the graph, the soil from this one, the soil texture is this one, and from this HWSD viewer, the soil is also the same. Texture is also the same. Then I will determine the P or probability number. For the first soil unit, I will use sand and clay, this one and this one, 51 and 27. For 51 and 27, 51 sand and 27, here it's arranged in the red section, so the soil permeability class will be in the red section. So red indicates moderate probability, so type 3. So type 3 here, see 3 is for the first soil map unit. For the second, it's 5, 24, 49, 24, 49 here in the clay section. So in the green section, which is 5, this permeability is slow, so type 5. So we have determined S and P such a way. Now we have to determine also M and OM, organic matter content. So organic matter content is related with this equation, and M related with this equation. So I need to compute this OM, organic matter, and M. So OM for this one, 1.72 times organic carbon. Organic carbon is this one multiplies with 1.72. So do for the rest in such a way. Now for for M is equals to percent silt plus percent very fine sand, which is 0 for this case. There is no very fine sand soil fraction, multiplies with 100 minus percent clay. As you can see, this is percent silt, this is percent of very fine sand, multiplies with this one, percent clay. So do for the rest in such a way. So we have determined this for input parameter for K factor equation. So now insert this for parameter into this equation. This is with Chalmers 1971. He developed this general equation. I use this general equation to determine K factor. So I just insert those 4 parameters, and I got this general value. But from this equation, the units of this K factor is in US unit. So I need to change into SI unit. For this case, SI unit is this one. So I need to multiply this value with 0.1317. So I got by multiplying this one, I got these values. These are the values for my K factor in SI unit. So what I'm going to do is I need to insert this K factor SI unit values into my ArcMap. So while you do, you have to be careful. Note that I have observed in some research papers that the annual soil loss rate is exaggerated number. This could be due to the misuse of the correct K-factor equation, as K-factor equation are region specific, so be careful while you choose the K-factor equation. Try to use your own study area K-factor equation. Do in such a way. Most of researchers simply use the available equation which are developed for a specific study area. So try to use equation developed for your study area solely. Try to use the proper unit. Both R factor and K factor are dimensionless. Most of K factor equations are units are in a US unit, so use units accordingly. The other is the developer must attain K values through site soil quantification by a geotechnical professional. So in this case, don't use nomographs. So use your study area nomograph rather. So this nomograph I used already may not represent your study area. Rather, I recommend you to use the general K factor equation. This is all about for today. You can determine the K factor in such a way. So I hope this video will help you determine the K factor. Thank you very much. Have a good day.